In the world of technology, some companies work tirelessly behind the scenes, driving the progress that shapes our everyday lives, yet remain largely unknown to the public. One such company is ASML. Based in the Netherlands, ASML has quietly become one of the most important players in the global tech industry. While it doesn't have the household name recognition of Apple, Microsoft, or Google, its role is absolutely essential. Without ASML, the devices we rely on daily, smartphones, laptops, electric vehicles, and even supercomputers, wouldn't exist in their current form. ASML specializes in manufacturing advanced photolithography machines, tools that are critical for creating the microchips powering modern technology. Its innovations have redefined semiconductor manufacturing, enabling faster, smaller, and more efficient chips that serve as the backbone of technological advancement. From artificial intelligence and autonomous vehicles to renewable energy and medical devices, ASML is at the heart of it all. Yet, most people have never heard of it. Why is that? And how has this low-profile company become so indispensable? Let's explore how ASML's cutting-edge technology has become the silent force driving global innovation.
Still, in its first year, the company successfully launched a first-of-its-kind machine that used precise rays of light to print tiny designs on silicon to make microchips.
We are the only provider on the planet of this critical technology.
At the heart of every technological device, from smartphones and gaming consoles to self-driving cars and advanced medical equipment, are semiconductors. These tiny chips serve as the brains of modern electronics, performing millions of calculations per second to enable the complex functions we often take for granted. But manufacturing these chips is an incredibly intricate process, requiring tools that can operate at almost unimaginable levels of precision. That's where ASML comes in. ASML is the world leader in producing photolithography machines, which are essential for creating microchips. Photolithography is a manufacturing process that uses light to etch incredibly small patterns onto silicon wafers, forming the circuits that make chips function. Over the years, as the demand for more powerful and efficient chips has grown, the required patterns have become smaller and more intricate. ASML has been at the forefront of this evolution, developing extreme ultraviolet EUV lithography technology, a groundbreaking innovation that has revolutionized the industry. EUV lithography enables chipmakers to produce semiconductors with features as small as a few nanometers, smaller than the width of a single strand of human DNA. This level of precision is critical for meeting the ever-increasing demands of modern computing, artificial intelligence, and data processing. Without ASML's advancements in photolithography, much of the progress in these fields would come to a halt. The company's machines are also instrumental in sustaining Moore's law, the principle that predicts the number of transistors on a chip will double approximately every 2 years. By pushing the boundaries of chip miniaturization, ASML enables the continuous improvement of computational power, which drives progress across industries. In many ways, ASML is the cornerstone of the modern tech ecosystem. The process that powers ASML's machines is nothing short of astonishing. To generate EUV light, ASML fires a laser 50,000 times per second at a tiny, falling droplet of tin. Each laser pulse vaporizes the tin, creating the extreme ultraviolet light needed to print nanometer-scale patterns onto silicon wafers. This process involves physics and engineering at a level so advanced that it feels more like science fiction than reality. The mirrors used in these machines, made by the German optics company Zeiss, are another marvel of engineering. These mirrors are so flat that if they were scaled up to the size of a country, the highest deviation from perfect flatness would be just 1 millimeter. This extraordinary precision is what allows ASML's machines to operate with unparalleled accuracy, enabling the production of chips that power our most advanced technologies. This level of precision is achieved through an intricate interplay of advanced materials science, cutting-edge engineering, and relentless innovation. Each component in ASML's machines is designed to function with exacting tolerances, ensuring the seamless integration required for producing next-generation semiconductors. This seamless integration is further enhanced by real-time monitoring systems and adaptive algorithms that fine-tune the machine's operations to maintain absolute precision. Together, these elements create an ecosystem where even the slightest deviation is corrected, guaranteeing the consistent production of cutting-edge chips. Given ASML's central role in the tech industry, it might seem surprising that the company isn't more well known. However, several factors contribute to its relatively low public profile. First, ASML operates in a highly specialized niche. Unlike consumer-facing tech giants like Apple or Samsung, ASML is a business-to-business, B2B company. Its customers are semiconductor manufacturers like Intel, TSMC, and Samsung Electronics, not everyday consumers. This means ASML doesn't need to market itself to the public, and its brand remains largely invisible outside of the tech industry. Second, the products ASML creates are incredibly complex and expensive. Its flagship EUV lithography machines cost over $200 million each and are the size of a small bus. These machines contain thousands of precision-engineered components and require an extraordinary level of expertise to operate. For the average person, the technical complexity of ASML's work makes it difficult to grasp, further contributing to its obscurity. Finally, ASML's European roots may play a role in its lack of recognition, particularly in regions like the United States, where the tech narrative is often dominated by Silicon Valley companies. While ASML is a global leader, its geographic location and highly technical focus have kept it out of the spotlight. However, its influence is undeniable. Without ASML, many of the tech giants we're familiar with would struggle to innovate at their current pace. ASML's dominance in the photolithography space didn't happen by chance. In the early 2000s, the company managed to outpace Japanese giants Nikon and Canon to become the sole supplier of EUV lithography machines. This remarkable feat has given ASML a near monopoly on the most advanced segment of the semiconductor manufacturing market. This dominance has significant geopolitical implications. Semiconductors are a critical resource in the global tech race, and ASML's technology plays a central role in this competition. The United States and China in particular are locked in a struggle to secure access to the most advanced chip-making tools. ASML, based in the Netherlands, finds itself at the center of this tug-of-war. The company's ability to supply EUV machines can influence the balance of global power, making its role not just technological, but also geopolitical. As nations scramble to secure their technological futures, ASML's machines have become a strategic asset, often entangled in international trade policies and export controls. This positions ASML as not just a key innovator, but also a pivotal player in the global chessboard of technological dominance. As international alliances and rivalries intensify, ASML's role extends beyond innovation, positioning it as a critical gatekeeper in the semiconductor supply chain. Its strategic significance ensures that the company remains at the forefront of both technological progress and geopolitical negotiations. As a result, ASML operates in a delicate balancing act, navigating export restrictions, international pressures, and the competing interests of global superpowers. This unique position underscores not only its technological prowess, but also its critical role in shaping the future of global technological landscapes. ASML's global impact. The impact of ASML's work extends far beyond the semiconductor industry. Its machines enable the production of chips that drive advancements in artificial intelligence, sustainable energy, healthcare, and more. For example, AI systems rely on powerful chips capable of processing vast amounts of data. ASML's EUV technology allows chipmakers to produce the advanced semiconductors needed to train and deploy these AI models, fueling innovation across countless industries. ASML also plays a crucial role in the transition to sustainable technologies. From electric vehicles to renewable energy systems, many green innovations depend on advanced semiconductors. By pushing the limits of chip manufacturing, ASML helps make these technologies more efficient and accessible, contributing to a more sustainable future. Economically, ASML's contributions are enormous. The semiconductor industry generates trillions of dollars in revenue annually, and ASML's machines are a critical enabler of this ecosystem. By allowing chipmakers to produce smaller, faster, and more cost-effective chips, ASML drives down costs and accelerates innovation across industries, creating jobs and boosting economies worldwide. On a geopolitical level, ASML's role is equally significant. Semiconductors are now considered a strategic asset, and countries are investing heavily to secure their own supply chains. ASML's technology gives nations the tools they need to compete in this high-stakes global race, shaping the future of technological and economic power. ASML doesn't operate in isolation. The company relies on a vast network of more than 5,000 suppliers to build its machines. This open innovation model makes ASML less of a traditional manufacturer and more of an integrator of the world's best technology. From optics and lasers to robotics and software, ASML works with partners around the globe to push the boundaries of what's possible. This collaborative approach is a key factor in its success, enabling the company to stay ahead in a highly competitive and fast-moving industry. By leveraging the expertise of its global partners, ASML ensures that every component of its machines represents the cutting edge of technology. This synergy not only drives continual innovation, but also allows ASML to adapt quickly to the evolving demands of the semiconductor industry. This adaptability is crucial in a sector where technological advancements occur at an unprecedented pace, requiring constant refinement and optimization. By staying at the forefront of innovation, ASML ensures that its machines remain indispensable to chipmakers striving to meet the ever-growing global demand for advanced semiconductors. This relentless pursuit of technological excellence not only solidifies ASML's leadership in the semiconductor industry, but also empowers its partners to innovate at unprecedented levels. Together, they drive breakthroughs that extend beyond semiconductors, influencing advancements in fields ranging from artificial intelligence to quantum computing. ASML's role in shaping the future. Looking ahead, ASML's innovations will continue to shape the future of technology. Conclusion: ASML might not be a household name, but its impact on the world is profound. As the leader in photolithography technology, the company is the backbone of the semiconductor industry, enabling advancements in everything from artificial intelligence and sustainable energy to national security and economic growth. Its EUV machines are some of the most advanced tools ever created, reshaping what's possible in technology and beyond.